Welcome to the Chapter 4 video about Lessons 2 and 3, Parallel Lines and Transversals. By the end of this lesson, we should be able to name the relationship that exists between the angles formed by parallel lines and a transversal. Let's start with what a transversal is. A transversal is a line that passes through two lines in the same plane at two distinct points. So we're not talking about skew lines here, and we're not at this point, just by the definition of transversal. They're not specific to parallel lines like these two over here. It's just two distinct lines. There's a line going through both of them. This dashed line here would be the transversal. Same thing over here. This is the dashed line crossing through these two lines that are on the same plane. There are special angle relationships formed when parallel lines are cut by a transversal. So from here on out, we're specifically looking at parallel lines being cut by a transversal. Not any old lines cut by a transversal, parallel ones. So we end up with four angle relationship: corresponding angles, alternate interior angles, alternate exterior angles, and consecutive interior angles. So let's take a closer look at the corresponding angles. There are more pairs of corresponding angles that are identified here. I'll label some more as we go along, but this angle in here is in the same spot as this one here. So when we say corresponding, we pretty much mean that they are in the same location on each of the parallel lines. So out of like these four angles that are created here and these four angles that are created here, both of these pink dots are in the top right-hand corner. Okay, if I grab another color, this angle is the bottom right-hand corner, that angle is the bottom right-hand corner, so those are corresponding angles. Another color here, top left and top left are corresponding angles, and then finally we would have bottom left and bottom left. And I don't know if you've noticed here with the pictures, and I know you can't always trust the images for sure, but with these at least, you can at least tell that this green one is obtuse, this green one is obtuse, this blue one is acute, same thing with this blue one being acute. So hopefully we can make the connection here that corresponding angles are congruent. So just to make the image a little simple here, I'm only identifying one pair of corresponding angles, these pink angles here. They're in the same location, referring to the two different sets of four angles here, and the corresponding angles are congruent. So now let's take a look at the alternate interior angles. The deal with alternate interior angles is understanding where those names apply, because the alternate applies to the angles that are found on either side of the transversal, so alternate sides of the transversal, and the interior refers to the relationship with the parallel lines. It is inside the parallel lines. So now that we know where these angles are located, there's actually only two pairs of them. One is already identified with the green dots. Okay, so this angle in here is on the bottom right-hand corner of this set of four. This one is on the top left. They actually are ending up to be congruent, and we can reference back to the corresponding angle relationship for that too. But they're alternate interiors because they're on either side of this dashed transversal that I have here, but they're also on the inside of these parallel lines. So the other set that I would have here would be these obtuse angles that now I'm kind of labeling with the blue. So those two angles are also alternate interior angles because they are on alternate sides of the transversal, but inside the parallel lines. And hopefully we've referenced here a couple times that these angles are also congruent. So alternate exterior will be very similar to alternate interior, except for they're going to be on the outside of the parallel lines. So still on alternate sides of this transversal, this one up here is on the right-hand side, this one down here is on the left, but now they're on the outside of the parallel lines. The parallel lines are here, this is the interior, but now these two angles are on the exterior. So these are alternate exterior because they're on opposite sides of the transversal, outside of the parallel lines. Now, if you notice their size, this is the obtuse angle, this is also an obtuse angle, and again, this could go back to corresponding angles and vertical angles and all that stuff. It all comes back to the fact, or down to the fact that these are also congruent. So we actually have three angle relationships from two parallel lines cut by a transversal that are all congruent. And this is important because we can use it to set angle values equal to each other to find missing values or missing angles or whatever the case may be. These are three relationships found from two parallel lines being cut by a transversal. The final angle relationship we're going to talk about from the parallel lines being cut by a transversal is actually consecutive interior. Now, consecutive interior also has another name. A lot of the times it's also called the same side interior angles, because now we are referencing, again, just like the alternate, that first word represents the relationship on the transversal. This same side also represents this transversal. So these are now on the same side of the transversal. Interior still referencing the inside space of the parallel lines. So these purple dots here are representing the same side interior angles. Okay? And if you'll notice here that this one looks to be acute and this one looks to be obtuse. Same thing over here. Let me use these ones that are clear. This looks like the obtuse angle. This looks like an acute angle. So this angle relationship will not be congruent. This angle relationship is supplementary. So just going to stress the fact that these angles that are created here on the same side of the transversal, on the inside of the parallel lines, are going to be supplementary, which means that they add to equal 180 degrees. I pointed out that the one angle looks to be obtuse while the other one looks to be acute, and it's true. Again, you can't trust the picture as far as exact measurements, but these are parallel lines and they are cut by a transversal. So these two, this obtuse angle plus this acute angle, will add to equal 180 degrees, and that is just from using a lot of the other angle relationships that we've already proven: vertical angles, corresponding angles, all of those things. So this is just another tool relationship to keep in your back pocket that we could use again to set up an equation to find missing values or missing angles. So when you start to look at practice problems, your first step is really to identify what the relationship is, so that way you know what relationship to use as far as setting up an equation. So in this one, we are finding the measures of the angle, but we can't find the measures of each angle without first finding the x value, because we don't have enough information for this. So we need to figure out what sort of relationship these angles are. And just where I'm putting this arrow, we can see that it's definitely interior, but the question is, based off of this transversal here, are they alternate or are they same side? So because these angles are both on the right hand side of this transversal here, these are same side interior angles, and that relationship is supplementary, which means that they're going to add to equal 180, and that is the equation I'm going to set up to solve. So using my algebra skills here's 3x plus 10 plus the 4x minus 5 equals 180, because they are supplementary, because they are same side interior angles. Combine like terms, start solving. X equals 25, so now I'm going to go ahead and plug in the 25 into each of these locations and find the actual measures of each angle. So plugged it in, simplified. The bottom angle here is 95 degrees, the top angle is 85 degrees. Now this next example, again, first job is to figure out what the relationship is between these two angles. And what seems to be extra confusing here is that there are three parallel lines, but because this one is on this parallel line and this angle is on this top parallel line, I'm just going to ignore this one in the middle here. So I'm not even interested in that one. And as we can see, hopefully we can tell that these angles are on the exterior. They are on the outside of those parallel lines that we're choosing to look at. And based off of the relationship with this transversal, this angle is on the left of the transversal, this angle is on the right of the transversal. They are on alternate sides. So they are alternate exterior angles which are congruent, which means I can set their values equal to each other. When I set their values equal to each other, I will be able to solve for x, and then just like the last problem, plug that x value into these expressions to figure out the actual measure of the angles. So solving for x, I got 12, and then plugging the 12 back in, I started down here and I got 131. Technically, because they are congruent, you know that this one should also be 131. But I'm begging you, please plug that x value into this expression as well to make sure that you do also get 131 as a check to make sure that everything when you were solving went correctly. All right, we're gonna start moving a little bit faster here. These angles are on the same spot in relation to these 4 angles and these 4 angles. It's in the top left, this one's in the top left. They're not both on the inside, they're not both on the outside. So because they don't have either of those relationships, I know, okay, well, let me just compare where they are. They are in the same spot. So these are corresponding angles which are congruent. So corresponding angles are congruent, and so that will be the relationship that we'll use to solve for x, which is what we're finding in this one. We know the angle measure already because they're congruent. This is automatically 139 degrees, but we're trying to find the value of x here, so I'm going to use that information to actually find the x value. And x equals 50. One more time, this is the hardest part, is figuring out what the original relationship is if you're going to be using congruence or supplementary, for example. But I'm going to be looking here. Both of the angles are not on the inside, both of the angles are not on the outside, and again, I'm referencing these parallel lines here. They are on the same side of the transversal, but they're not both on the inside or both on the outside. So I have to look at the fact that they're both in the top right-hand corner relationship as far as these 4 angles go at each place. So this is the top right hand, this is the top right hand, which means again that they are corresponding angles, which is congruent, which means I can set them equal to each other and solve for x, and then find the measure of the angle to actually answer the question. So I got x equals 3 from solving. Then I plugged in 3 for x values, and I got 36 degrees. Now this is a very good example of when you can't trust the pictures 100% for their actual measures. I can trust the pictures to know that they are in corresponding positions, and that I know from that they're going to be congruent. However, these angles clearly are obtuse, but my measures are saying that they're 36 degrees. So just because my measures say that they're acute, but the picture shows obtuse, that doesn't mean you're wrong. This is all done correctly. It's the corresponding relationship. We get a small x value, we plug it in, and we get 36 degrees. It just happens to not match the picture. All right, so this is the last example in your notes here, and I know it looks awfully confusing, and like a lot of things are going on here, but you'd be surprised how much you can actually figure out just by being given these 2 angles here. You should be able to figure out all these other 14 missing angles just by being given these 2. Please understand these are the 2 parallel lines. This is one set of transversals that should let you move between these angles here, and this is another transversal that will let you use these relationships over here. Do not compare these angles to these angles because they are not being cut by the same transversal. So you're going top to bottom and top to bottom. Focus on the transversal. So go ahead and take a minute, see what you can come up with on your own before you continue on and check your answers. So I hope you did a good job here, noticing a whole lot of pretty much vertical angles and supplementary, and then moving. So vertical angles and supplementary would get us this, but then we can jump to these angles up here by our relationships with corresponding and consecutive interior and alternate exterior and all of that stuff, and the same thing over here. So really just 4 different answers that are just all over the place. So this concludes our lessons 2 and 3 about parallel lines and transversals. So the relationships that exist between parallel lines and a transversal are that pairs of angles are either congruent or supplementary, depending on where they are located.